All right, everybody. Hey, this is the alternate lecture assignment for January 18th for Forestry 131, Forest Measurements, both sections 1 and 2. This is going to be chopped up in two, maybe three 15-minute segments. The recording device I'm using only goes 15 minutes at a time, so you'll need to be clicking on those segments one at a time to finish this. So, just wanted to mention to you all first of all that because both the Wednesday and Thursday lab had been canceled today or yesterday and today, that we have two alternate assignments, and they're basically doing an orienteering course around on the outside of the campus here. Not too far from the building. The Tuesday lab already completed it. Not very hard. It takes about an hour and a half. You must carve out an hour and a half between now and your next lab period. Meet up with somebody and go in teams of two. And you need your hand compass. You need boots. You need some good heavy pants because you're going to be walking through cat briar and stuff. So come see me and I can help you get started with it. Or if you want to get started on your own, that picnic table outside as you're heading away from our classroom building, you'll see a picnic table. There's a tree, a big white oak tree with a flag wrapped around it, and that's station number 1, so you can get started there. But I'm more than happy to walk you out, and so would Ron and Andrew, I'm sure. So I'm going to do a quick review of some of the things that we covered last lecture. Okay, and that was in presentation 2. It was reading maps, conversions, map scales. So again, just a kind of a reiteration, how, what are some different scales that we work with. And so you need to be aware of a lot of these different scales, what a chain is, how many feet in a mile, how many chains in a mile. We do play a little bit around with some of the metric units. Walk your way through some of these exercises, and that'll certainly help you in making some of those conversions. Okay. But what I wanted to get again into was this concept of map scale. Okay, it's so very important that you understand how map scale works. And so if you're having any trouble with this, please come see me. Okay, more than happy to work with you on it. But essentially, we have 3 different types of scale. Graphic scale is where you actually have a graphic, like a scale bar or something drawn out, and then the what that scale bar represents. And again, you have to explicitly state the units. Okay. I think, and I brought out in lecture, that if I have a scale bar on a map over here, like in that picture right there, and I have the units written down there, let's say 2,000 feet. If I take that and put it on the copy machine and blow it up or make it smaller, that scale relationship still exists because it's a graphic. That graphic is part of the image, and so as the image explodes or gets larger, so does the graphic. So that's the only one of these 3 scales that you could put on a copy machine and make larger or smaller, and it'll work. It'll maintain the same relationship. The other 2 are written out in text. Okay, so in this case, the verbal expression is just that. Okay, you're verbally expressing what that scale is, and so again, the map distance, all right, is on the left. The ground distance is on the right, and that relationship is just established by that equal sign. So notice that I'm explicitly stating what map units I would measure in and what ground units they would represent. Okay, so 1 inch equals 2,000 feet. Every time I measure an inch on the map, that represents 2,000 feet. Okay, and then the third example is this very, very commonly used is this representative fraction. It's either written as a ratio or it's written as a true fraction. Okay, so either one of those ways of writing that are correct. And Notice there are no explicitly stated units on the representative fraction, and that's because what this is stating is whatever units I measure on the map side, could be inches, could be centimeters, that represents 24,000 of those same units on the ground. Okay, so a little bit of math here. If I measure, if I'm using a 1 to 24,000 scale and I measure 1 inch on the map, that represents 24,000 inches on the ground. So what does that represent in terms of something a little easier to understand than inches on the ground? How about feet? 24,000 divided by 12 inches per foot actually ends up equaling 2,000 feet. So a 1 to 24,000 scale map, which is one that the scale that we will be using when we're using the topographic maps in class. This scale actually is exactly the same as this scale. Okay, they're equivalent, right? So I just wanted to point that out to you. That's very important. Could pop up on a quiz on Tuesday. Talked about different types of map scales. If we're trying to zoom, if we're trying to see a larger area, like let's say all of Haywood County or all of North Carolina, then we're going to reduce the scale. The scale gets smaller. Smaller scale maps represent larger areas, okay? Larger scale maps represent smaller areas, okay? And if you think about it in terms of this number right there, if you take a look at that 1 to 24,000 scale and compare it to, let's say, the one that's given here, okay? If I just drew a fraction, or if I turn that into a fraction, 1/63,360, and thought about it in terms of slices of pie, 1/63,000th of a slice of pie is a smaller slice of pie than a 1 to 24,000th slice of pie. Okay, a little hard to conceive of, but that's the case. Okay, 1/24,000th of a pie is a bigger piece of pie than a 1/63,000th of a pie. Basically, what I'm trying to tell you is that this number is a larger number than that number. Okay, so this is a smaller number. 1 inch represents 63,000 inches on the ground, so it covers a larger area. So that's a smaller scale. To think about it in terms of the numbers themselves, if you turn them into actual fractions, this number is smaller than that number, so this scale is a smaller scale. Okay? And by virtue of the fact that 1 inch equals 63,000 inches on the ground, or in reality that represents 1 mile on the ground, as opposed to 1 inch representing 2,000 feet on the ground, which is roughly a half a mile, then you could put a lot more area on a map at that smaller scale. So I could cover all of Haywood County as opposed to maybe just Lake Junaluska. All right. So there's pros and cons of each. If I can get to see all of Haywood County on a smaller scale map, I can be able to, look at things within the county level and see how things are in relationship to each other. What I'm missing is greater detail. If I really want to get a better handle as to what Lake Junaluska looks like, I'm going to use a larger scale map. Okay, covers a smaller area, but it's in much greater detail. Okay, so that's how we use different types of maps at different scales for different things that we need. So just remember that ratio is really what's describing the scale. 1 to 63,000ths as opposed to 1 to 24,000ths. Okay. So then we played this game a little bit. I'll go through some of these answers for you really quick. This is a 1 to 24,000 scale map. I've measured 2 0.5 inches across Lake Junaluska. All right. So the first thing I would do is convert that to feet. All right, to a verbal expression. It's a little easier to think about. Besides, that's what I'm looking for here is feet. Okay, so I would take 24,000 divided by 12 inches per foot. Okay, so I know that 1 inch equals 2,000 feet. I would take the 2.5 inches, multiply that by 2,000, and my answer would be that that distance is 5,000 feet. Okay? Pretty easy. So what's that distance in miles? Well, it's not quite a whole mile. Let me pull up my trusty calculator here. I got 5,000 feet divided by 5280. So that would be about 0.95 feet or miles, okay? So, or I might just say 0.9, okay? If I want to figure out what that is in kilometers, I would multiply that by 1.61. And it's about 1.5 kilometers. Okay. Also, if it's 5,000 feet and I know 66 feet equals a chain, let's see if I can clear this. Come on, where are you? There we go. Nope. Okay. I guess you just start typing. So 5,000 feet divided by 66 feet per chain. So it's about 75.8 chains. Now remember, 80 chains makes a mile, so, and that's not quite a mile, it's about 9/10 of a mile. So that makes sense, right? 75 chains is a little bit less than 80 chains, which is 1 mile. So it's always good to try to kind of rationalize your answers and see if it makes sense based on other things that you know. Okay, well, I'm going to stop here and create a couple of other slides for you too, or presentations. Okay, so make sure that you click on the second presentation. Ready to go.